mode of 8085. Okay. So let me start. So in case of working with 8085, to perform any operation, what we generally do, we have to give a proper instruction to the microprocessor. Then obviously that instruction should be dealing with some sort of data. That data should be either kept in some memory, or that will be in some external peripherals. That means always the data over which we are working, we are providing some sort of instruction like addition or subtraction or maybe some logical operation. That data is located at some memory location or in some register location or in some external peripherals. That data is located, right? And we have to work over that particular that particular data, right? So for each instruction there are three specific things. First of all, which type of operation we need to perform, then address of the source of the data, that means first from where we need to fetch my data, where we need to get my first data. So that is the first thing, address of the source data. And after doing the operation, what is the destination? That means where I should store my result. Okay, so this is the main job which is being performed in any case of any microprocessor. Now, what is addressing mode? The addressing mode is the method by which the addresses of the source of the data or the address of the destination result is given in the instruction. So that means always by which we can take the data, the instruction by which we collect the data from the source, and the mode by which we are storing the result. The data is stored in some place. So in which way we are actually getting my data, in which way we are storing our data, in some address location, in some memory, in some register. So that is called the addressing mode. The term addressing mode refers to the way in which the operand or the instruction is specified. Now there are various types of addressing modes. Generally 5 types of addressing modes are there in 8085. Those are direct addressing mode, register addressing mode, register indirect addressing mode, immediate addressing mode, and implicit addressing mode. These are the 5 types. We have to know about all these 5 types of addressing modes. First of all, let me come to the direct addressing mode. As the name suggests, that means directly we are pointing out to a particular address. So that is called a direct addressing mode. In this addressing mode, the address of the operand is given in the instruction itself. As I have mentioned, that already the location or the address is mentioned in the instruction. For example, LDA 2500H is a particular instruction. LDA okay, that is a particular instruction, load accumulator. We will be learning about instruction set in our next class. Just right now, for your understanding, this is one instruction that can be given to your microprocessor 8085. The instruction is written in such a manner that LDA 2500H. What does it mean? It means that load the contents of the memory location 2500H in the accumulator. That means, as you know, there is a bank of memory, right? And a particular location, a particular address is there, which is 2500 hex. H denotes hex. So that 2500 hex, that is the particular location where some 8-bit data has been stored, right? Now the instruction says that, okay, fetch your data from 2500H, that particular memory location, that particular address location, fetch that particular data and store that particular data into your accumulator. So that is something like directly you are fetching one data from your memory location and you are providing that particular data directly into your accumulator, that data, 8-bit data. So that is something like directly you are storing. So that is why it's called direct addressing mode. So what is the source? Source is 2500H. That is the source. Instead of that, you can write down 4000H. So that means that address location 4000. That particular address location, the data, what the data has been stored right at 4000H location, that will be fetched and that will be stored in the accumulator. So destination is my accumulator and my source is the directly given as memory, right? So that is something like direct addressing mode. Now coming to the register addressing mode. Next is the register addressing mode. Now in this mode, obviously the address is not something like 4000H or 2070H. It's not like that address location we are directly providing. Instead of that, we are providing a particular register, and on that particular register the data has been stored and we want to fetch that particular data. Likely the operand is a general purpose register. That means we are having a general purpose register, as you know, B, C, D, E, H, L, these are the general purpose registers are there. So within that general purpose register, some data has been stored and we want to receive that particular data, or we want to fetch that particular data and we want to load that particular data into accumulator. So what would be the instruction? The instruction would be MOV move A, B. That means it means that the content of B register, the content what the data has been stored in that particular general purpose register, what the contents stored right what they are, fetch that particular data and put that particular data into your accumulator A. So make sure that this is the destination. First of all, we write down the destination and then we write what is the source. So B is the source and A is the destination. Okay. Next is similarly we are having register indirect addressing mode. It is the mode, the address of the address is denoted in a register pair, that is indirectly. Make sure that this time we are having one register pair, likely HL pair is there. So on that HL pair, on that pair 8-bit plus 8-bit, total 16-bit data can be stored, 16-bit information can be stored. Now that 16-bit information is nothing but locating one particular address. Make sure about this one. Now what you are actually writing or what you are actually providing the instruction is that go to that particular register pair, find out what the address given on that register pair, and then pick the data of that particular address location and load it in the accumulator. Okay. So something it is given, that means in your HL pair or that particular register pair, there you are having one memory location address. Okay, and you are denoting that okay, go to that particular address which is mentioned in my HL pair, go to that particular address, find out what the data right over there, pick that data and load it in the accumulator. So that is something like indirect mode of addressing. So there are, as you can see, direct. First of all, I have said that direct mode of addressing. That means in that time immediately you are loading to the accumulator some address location 2050H. The data which is stored in that particular address location you are storing directly to the accumulator. That was the first direct. That was this one, direct addressing, LDA. Okay. Next is move. That means you are in your particular register. the general purpose register, it has got some sort of data which is stored. So that is register addressing mode. On that particular register, you have got your data and you are fetching that data, you are calling that data in your accumulator. That is the register addressing mode. Coming to the next one, that is register indirect addressing mode. That means you are using one particular register pair. On that register pair, one address location has been mentioned. Now you are actually copying that specific address location, that specific address location's data directly, indirectly in the accumulator. So that is, move a comma m. Now m denotes is the HL pair, that particular memory location which is stored in the HL pair. So that means m is the memory location specified by the HL pair, okay, and a means accumulator is the designation, okay, destination. And then we are having the MVI command. MVI is move immediately. In this particular case, immediately the accumulator is loaded with some particular data. So it doesn't require any sort of either other memory location or HL pair or something like that. No, some address is not required. So directly, immediately you are storing. That means in the accumulator, suppose like MVI A05H, you are this particular instruction you have provided. What does it mean? It means, this particular data 05 is that particular data, 8-bit data. This 8-bit data, now why it is 8-bit data? Because 5 would be denoted by 4 binary bit, 0 will be denoted by 4 binary bit. These are the hex. So that is why 05, 4 plus 4, 8-bit data. Okay. So this 8-bit data will be directly stored in the MVI A, that means in the accumulator. So accumulator is the designation and 05 is the directly data. So that is immediately you are storing. Okay. Instructions are something different. These are the LDA, load accumulator, the address location. That's that particular address. Coming to the next to us, move, and then we are having MVI. Okay. And lastly, this one is the implicit addressing mode. What is that? If the address of the source of data as well as the address of the designation of result is fixed, then there is no need to give any operand along with the instruction. Okay. So that time you can just provide one particular instruction. If your source is fixed, your designation is also fixed. Likely, CMA, complement accumulator. That means this particular instruction is what it will do. The source is accumulator, the designation is also accumulator. What it will do? The data which is stored in that particular accumulator, it will just complement the data and the result is also being stored in the accumulator. Just you are inverting the data. So that operation doesn't require any other memory or address fetching. It doesn't require that. Only one what you are doing, you do not require operand, just the opcode is enough. This is called actually the opcode. This is called the opcode, and the next part is called the operand. Okay, so there is no operand is required, only opcode is enough. Okay. So this is something like complement accumulator is one of the example of such implicit addressing. So make sure these are the 5 addressing mode. Direct addressing mode, something like the addressing mode by which we are providing something like LDA, load the accumulator with some address, 16-bit address line. So that is maybe 4000H. 4000H, that is the address location. There some data has been stored. Fetch that data and store in the accumulator. So that is something like direct addressing mode. Next is register addressing mode. That means something like move A comma B. That means the data which is being stored in B, now you are moving that data into A. So that is something like one register is there which has stored one 8-bit data. That data you are storing in the accumulator. That the addressing mode you are trying to make. Next is register, but indirect addressing mode. What does it mean? Something like move A comma M. It means that HL pair, as you know, there are some general purpose registers are there which can be paired, likely the HL pair. Now HL pair has got total 16-bit information. That information is actually denoting one particular address. Now what you have to do, what the microprocessor will do, if I got one instruction MOV A comma M, means the HL pair, it is denoting some address location. It will fetch the data of that particular address location, and the designation will be accumulator. That means that data will be coming back to the accumulator. So that is something like register indirect addressing mode. Next is immediate addressing mode. Immediate means MVI, move immediately accumulator, something like 05H or 01H, something like that. Means accumulator should be loaded. There is no further memory or registers are required. Simple, the accumulator data will be 01H. That means only that you are storing a fixed data in the accumulator. So that is something like immediately addressing mode. And lastly, implicit addressing mode, it doesn't require also any further address location. If your designation and source both are same, likely the accumulator, likely that complement of accumulator, CMA instruction. So whatever the data which has been stored already in the accumulator, that you are actually complementing, and the data result, the complementary result also you are storing in the accumulator. So these are actually the different types of addressing modes. We'll be discussing in our next class about the instruction sets. Now instruction sets, there are various instructions available, though here we have gone through little bit 4 or 5 examples of that one. We'll be going for that one further in the instruction mode. Thank you very much.